Hello students, in today's class we are going to study acidity of carboxylic acids, and in particular we are concentrating on aliphatic acids. Carboxylic acids are acidic in nature. The name itself is revealing that they are acidic. Why? Because the term we can see here, that is carboxylic acids. But these are weak acids as compared to those of mineral acids such as nitric acid or hydrochloric acid and that of sulfuric acid. So if carboxylic acids are called as acids, then we have to express the strength of their acidity, right? So therefore we are having a heading called as expressing the strength of carboxylic acids. So carboxylic acid is an aqueous solution. An acid is going to ionize in a systematic manner. That we have written a single step reaction where you can see that carboxylic acid in water, that is aqueous medium, it is going to dissociate to produce a carboxylate anion. It means that one of the hydrogen, this hydrogen of carboxylic acid will be given to water. As a result, we are having here carboxylate anion, and the H plus that is received by this water molecule becomes what? Hydronium ion. As we have already studied the Arrhenius concept of what? Acids and bases, isn't it? Any substance which gives H plus ion in aqueous condition is called as an acid. So here carboxylic acid is donating H plus to this water, right? So therefore carboxylic acid are nothing but water, acidic in nature. And other definition with respect to Bronsted theory, proton donors are called as water acid. So here carboxylic acid is giving water 1 H plus to this water molecule. So again we can say that these are water acidic in nature. Now the strength of the carboxylic acid is expressed in terms of a dissociation constant called as what? K subscript A. Okay, and this dissociation constant is called acidity constant, and this acidity constant whose value is dependent on temperature, or we can simply call it as it is a temperature dependent constant. Apart from expressing the acidity of carboxylic acid in terms of Ka value, nowadays the strength of the carboxylic acid is also expressed in terms of what? pKa value, which is nothing but what? Log of inverse of Ka, or we can simply call it as minus log of what? Ka. Now let us try to understand what is this actually Ka. Ka is nothing but it is the ratio of molar concentration of a product, right, divided by molar concentration of what? Reactant. So in the initially first reaction I have taught you that carboxylic acid will be giving H plus ion to water, right? So therefore these are the products. Okay, the numerators whatever I have written, those are nothing but what? Products, and the denominator whatever I have written here, these are nothing but what? Reactants. So altogether we can say that Ka is nothing but what? It is the ratio of molar concentration of product divided by molar concentration of what? Reactant. So since water is taken in what? Excess, okay, so therefore its molar concentration remains what? Constant, or we can simply call it as what? Unity. So therefore one can say that Ka is nothing but what? The molar concentration of a reactant, molar concentration of product to that of the molar concentration of the reactant. We have to remember one note here. That note is very simple. Larger the Ka value, stronger will be the acid. If we are expressing the acidity constant in terms of Ka value, then one should remember that if the Ka value is larger, then stronger will be the acid. And similarly, if we express the acidic strength in terms of pKa value, then smaller the pKa value, stronger will be the what? Acid. So here we are having Ka values of a few aliphatic carboxylic acids. So in this column we are having the acid, and here we are having the Ka value. The first one is formic acid. Formic acid has a Ka value of 17.7 into 10 to the power of minus 5. The second one is acetic acid. So acetic acid, it is having 1.75 into 10 to the power of minus 5, right? And if you see the third one, in the case of the third one, now this is the functional group, right? And here this is the alpha carbon atom, and on alpha we are having here Cl, so therefore it is called as alpha chloroacetic acid. So there is a halogen in one of the hydrogen of the alpha group. So halogens are electron withdrawing groups, so therefore they withdraw the electron. When they withdraw the electron, in this manner the electrons are what shifted towards halogen, so therefore acidic strength goes on what increases. So here the Ka value, you can see that it is 136 into 10 to the power of minus 5. So therefore alpha chloroacetic acid is a stronger acid when compared with 1 and 2. And the fourth one, in the case of fourth example, you can see that this is the alpha carbon atom, but alpha carbon atom is having what? 2 halogen atoms, right? So therefore it becomes what? Much more stronger acidic in nature. So therefore the Ka value is 5530 into 10 to the power of minus 5. And if you see the fifth example, in the fifth example, so here what happens? In the fifth example there was some correction, I have just corrected it, right? So here this is the alpha carbon atom, and this alpha carbon atom is having what? 3 halogen atoms, so therefore it is called as alpha trichloroacetic acid. Since there are 3 halogen, that is chlorine atoms, so therefore the Ka value is very large when compared with that of 3 and 4. Here it is 23,200 into 10 to the power of minus 5. In the case of sixth example, so totally there are 4 carbon atoms, so that is 1, 2, 3 and 4. So it is simply called as butanoic acid, right? So there are no halogens and all, so therefore the Ka value is just 1.52 into 10 to the power of minus 5. But whereas in the case of the seventh example, right, so this is the functional group which is having highest priority, 1, 2, 3 and 4, right? But on second position we are having what? Chloro, which is electron withdrawing group, so therefore it is called as 2-chlorobutanoic acid. Since one halogen atom is present on second carbon, or we can call that carbon as alpha also, so it is also called as alpha chlorobutanoic acid. Since halogen atom is going to withdraw the electrons, so it increases acidic strength, so therefore the Ka value becomes 139 into 10 to the power of minus 5. In the eighth example, students, so again there are totally 4 carbon atoms. First carbon, this is second carbon, this is third carbon, and this is fourth carbon. But the fact is that the halogen atom is present on beta carbon atom. Here this was alpha, but now this is called as beta, right? So what is the nature of halogen? To withdraw the electron. But here the halogen atom is far from this COH group, right? So therefore with increase in the distance of the halogen atom from the functional group containing what? Hydrogen, if it increases means acidic strength goes on what? Decreases. It means Ka value becomes what? Less. Larger the Ka value, stronger is the acid. Lesser the Ka value, weaker is the acid. So therefore on comparing 7 and 8, in 8 halogen atom is far away from the functional group COH, so therefore the Ka value is 8.9 into 10 to the power of minus 5. In the ninth example, so in the ninth example again there are 4 carbon atoms, so this is first carbon, this is second carbon, this is third carbon, and this is fourth carbon. So this becomes alpha carbon, this is beta carbon, and this is gamma carbon, right? So the halogen atom is very far from the functional group. Okay, functional group is here COOH. So with increasing the distance of the halogen, whose nature is to withdraw the electron, if it increases with the distance, then Ka value goes on what? Decreases. And here the Ka value is 2.96 into 10 to the power of minus 5. And now in the case of 10th example, we can say that on alpha carbon atom, this is the carbon atom which is simply called as alpha, right? On alpha carbon atom we are having what? Fluorine. the most electronegative atom. So therefore the Ka value is 260 into 10 to the power of minus 5. But actually one should remember that down the group, in case of halogens, electronegativity goes on decreases. So in 11th example, if I consider the 11th example, so this is the alpha carbon atom which is having what, Br, that is what, bromine. So bromine is somewhat less electronegative when compared with the fluorine. So therefore the K value is just 125 into 10 to the power of minus 5. And in the case of last example, that is the 12th example, so this is the carbon which is called as alpha carbon. I call it as alpha because it is adjacent to what, a functional group. That one has to what, remember, right? So as we already know that iodine is what, less electronegative when compared with that of bromine and that of what, fluorine, right? So therefore the K value is just 67 into 10 to the power of minus 5. Now students, we have to study the effect of substituents on the acidic strength of aliphatic carboxylic acids. Okay, effect of what, substituent. These substituents are of two types. One is electron donating, or simply called as electron releasing. Other one is electron withdrawing. If these groups are present on carboxylic acid, then how these groups are going to affect the acidic strength of the aliphatic carboxylic acids, we are going to study. Now I have written a simple equation. You can see that carboxylic acid, it will undergo partial ionization to produce what, H plus. Okay, not completely. If it was completely, means we would have got complete ionization, but here I have written what, a double headed arrow mark. It means it is reversible in nature. What actually happens here is that this bond, okay, the OH bond between this oxygen and hydrogen, so oxygen is more electronegative, right, and this bond will be taken by what, oxygen, and H is expelled in the form of H plus, right? And that H plus is present here now, right? This is nothing but H plus. Meanwhile, oxygen bears now what, 3 lone pairs of electrons, right? Either you can write 3 lone pair of electrons, or you can simply write 1 negative charge over that oxygen atom. So this is called as a carboxylate anion, right? Now we have to study, if at all, if one group is present on this R, in fact this is what, a carbon here, okay, if an electron releasing group is present, ERG, electron releasing group is present, what happens to this H plus? I will change with another color here, okay, that is what I'll make it again red now. Okay, what happens to this H plus? How this electron releasing group is going to affect to the release of H plus ion, that we have to what, study here. So I'm going to consider the A now, okay, that is with respect to what, effect of electron releasing substituents. Electron releasing substituents are going to show plus I effect, that is plus inductive effect, which we have learnt in earlier classes, right? Now these electron releasing groups, such as alkyl groups, they are going to decrease the acidic strength. Remember students, very important, alkyl groups are going to decrease the acidic strength of carboxylic acids due to the following reasons. The first reason is that because of this plus I effect of alkyl group, the electron density on oxygen atom goes on increases. Now let us try to understand how it is going to increase. Okay, I'll be writing here a simple representation, right? R, then followed by C, then followed by double bond O, then followed by single bond, and what, OH, right? If R is electron donating group, then what it has to do? It is going to give electron. So I have written here arrow mark. You can see that it is going to give the electron. These electrons are taken by carbon, right? And in turn, these electrons are given to this oxygen atom, right? Are given to this oxygen atom. Already here, already here, oxygen is having what? 2 lone pair of electrons. Furthermore, this R is also giving what? Electrons to this what? Oxygen atom. Now my question is that already we know that oxygen is electronegative, right? and if it is electronegative, it has to take the bonding electrons of this OH bond towards itself. But here somebody is giving electron. Who is that somebody? Alkyl group is what? Giving the electron to this carbon, and this carbon is giving electron to this oxygen. So therefore one can say that by receiving electrons from alkyl group, this oxygen, the tendency to take the bonding electrons of this OH bond towards itself by the oxygen atom goes on decreases. It means that this bond remains here only. Which bond? OH bond remains here only. If OH bond remains here only, then H is not coming outside in the form of what? H plus. And if it is not coming in the form of H plus, then this carboxylic acid is what? Weak acid. That's what I have explained here. Now let us try to understand it. I have written here, and its electron accepting tendency in the OH bond decreases accordingly, and the release of H plus ion becomes very difficult. Therefore, greater the magnitude of plus I effect, weaker will be the acid. Now, the second reason is that these electron releasing group, they are going to destabilize the carboxylate anion. How? The question arises. How it is? By increasing the magnitude of a negative charge on the oxygen atom. I have written here it. That is nothing but what? Oxygen atom. So if I take a representation here, okay, R then followed by C, double bond O, then followed by O and H, right? So this R is an electron donating group. So what we'll do, it is going to give electron that are given to this carbon. Carbon is again giving electron to this oxygen atom. Already oxygen is having one lone pair of electron. Excess of electron density will be more on this oxygen atom. So if it is excess, it is going to what? Destabilize. And if it is destabilizes, then we can say that as a result, the acidic strength is going to what? Decrease. So therefore, in the view of the above observation, the relative acidic strength of a few carboxylic acids I have taken here. So those acids are nothing but here we have written, right? The first one is formic acid, right? So there is only one carbon, it is called as methanoic acid. In the second case, here there are two carbons, so therefore it is called as ethanoic acid. In the third one, we are having here 2 plus 3, so therefore it becomes propionic acid. And the last one, there are 3 plus 1, that becomes what? 4, so it is called as butanoic acid, right? Now let us try to understand that in case of formic acid, there is no R group. Here we are having simply one hydrogen, right? Hydrogen is not an electron donating group, okay, neither what electron withdrawing group, okay. So there are no alkyl group, and when you compare with that of what, if I say this as first one, and this is second one, and this is third one, and this is fourth one, right? If I compare formic acid with the remaining 3, that is 2, 3 and 4, formic acid is a stronger acid when compared with water. 2 carbon carboxylic acid, that is ethanoic acid. Why? Because in case of 1 there is no alkyl group, but in the case of 2, that is what ethanoic acid, here we are having 1 carbon, that is what methyl group. If I compare this 2 with that of 3, that is what propionic acid, here we are having ethyl group, right? So if I compare this methyl and ethyl, ethyl is having what? More electron donating tendency when compared with what? Methyl. So therefore we can say that ethanoic acid is much more stronger acidic when compared with what? Propionic acid. And in turn, propionic acid is much more stronger acid when compared with what? Butanoic acid. So therefore, on moving from left to right, the acidic strength goes on decreases. This point you have to what? Remember. So far we have learnt the effect of electron releasing substituent, right students? Now we are going to concentrate on effect on electron withdrawing substituents, right? It means these are electron withdrawing, they take the electrons from the carboxylic group. So these groups are showing which type of effect? Negative inductive effect, that is called as minus I effect, right? the electron withdrawing groups, which are those particularly what, halogen atoms or that of nitro group. So these groups are withdrawing. When they withdraw the electron, they are going to increase the acidic strength by decreasing the magnitude of negative charge on the carboxylate anion, and they are going to stabilize it. What it means, it is nothing but carboxylate anion, and therefore the release of H plus ion becomes very easy. Now let us have the one example here in a simple manner. Okay, I will be taking here CH2, right, and I'll write here one Cl, right, then followed by C double bond O, then followed by OH, right. So this is functional group. Okay, I hope you can see this. This is called as functional group. Next carbon adjacent to functional group is called as alpha carbon. Alpha carbon is having one electron withdrawing substituent, that is called as chloro group. So the name of this compound is called as alpha chloroacetic acid. So what does this alpha chloroacetic acid does with respect to the H plus ion present in the functional group, right? So it is an electron withdrawing, so it has to withdraw the electron. So it is going to withdraw the electron from this carbon atom, right, and this carbon is adjacent linked with this carbon, so the electrons are moving in this direction, right, and the electrons that are present on this oxygen, okay, oxygen is more electronegative. In fact, here we are having halogen, so therefore these electrons are moving in this direction towards the halogen. When such thing is happening, then what does oxygen does? Oxygen atom will take the electrons that are present in the OH bond, and it will expel this H in the form of water H plus, right, and when it is expelling, negative charge is present on oxygen atom right now, okay, but this negative charge is stabilized by the electron withdrawing nature of this Cl. So therefore in the explanation we have learnt that these electron withdrawing group are going to stabilize the carboxylate anion, and thus making the release of H plus ion very easy. Now if we know that if electron withdrawing groups are going to increase the acidic strength of carboxylic acids, then the acidic strength is influenced by the following factors. Factor number 1, that is magnitude of I effect. Okay, I have to speak in terms of what minus I effect, that is very important. So magnitude means what? Nature. So in the nature, if you see, that is, if I consider here NO2 group and what that of what halogen, which is the strongest electron withdrawing group, that is nitro group is the strongest electron withdrawing group. That refers to what magnitude or what the strength of minus I effect, right? Second one is the position of electron withdrawing group on the carbon atom chain, on the what carbon atom chain relative to the what carboxylic functional group, right? So here what we have to learn is that I'll be taking a simple representation here. Already we have learnt, but yet to make you aware. Okay, so I'll take here then followed by C double bond OH. Okay, now here I'll keep what one Cl. In the other example, what I'll do, I'll take some 4 carbon carboxylic, right, and I'll keep the Cl on this carbon. So if this is the functional group, now this is called here as alpha, and if this is alpha, now this is what beta. Okay, now concentrate on the second point, that is B, right? Position of electron withdrawing group on the carbon atom chain relative to this what functional group. Okay, now to these two examples, what I will write this as what A, and this I can call it as what B. In the case of A, this halogen is present on alpha carbon atom. It means the position of this halogen on the alpha carbon atom is very near to this what functional group. It means it can withdraw the electron more easily. So therefore A is what a stronger acid when compared with that of B. Why? In case of B, the halogen atom is present on beta carbon atom, right? So this Cl is far away from this what functional group. So therefore A is much more stronger when compared with that of what B. So that is the meaning of the what is this option B here, position of electron withdrawing group on the carbon atom chain relative to the functional group, that is COOH group. And the next one is C, that is number of electron withdrawing group. Okay, how many electron withdrawing groups are present in a given molecule. Fine. So based on the above observation, that is ABC, I have taken what here some examples that are going to determine the acidic strength of few alpha chloroacetic acids. Okay, few alpha chloroacetic acids, right? So the examples, you can see that I call this as what, 1, this as 2, 3 and 4, right? So in the case of first one, you can see that this is the functional group, that is what, C double bond O and OH. Okay, in all it is the same, right? That we have to what understand, that is carboxylic functional group, right? Now I call this carbon as alpha carbon, but to this alpha carbon there are 3 chlorine atoms, so all are electron withdrawing. This also withdraws electron, this also withdraws electron. So when they are electron withdrawing, they withdraw the electron from this oxygen atom. So this is the oxygen atom here, right? So what happens is that here, students, so these bonding electrons are going towards what, this oxygen atom, right? So therefore H plus is very easily expelled outside in the form of what, H plus. Since there are 3 chlorine atoms, so all the 3 are going to withdraw the electrons, so therefore we can say that trichloroacetic acid is the strongest acid, right? So therefore I'll be writing in this manner, it is the strongest acid when compared with the dichloroacetic acid. Why? Because in the case of dichloro, only 2 chlorine atoms are present on this alpha carbon, right? And in turn one can say that dichloroacetic acid is much more stronger acid when compared with monochloroacetic acid, because in case of monochloroacetic acid we are having only 1 chlorine atom present on alpha carbon atom, and in turn monochloroacetic acid is much more stronger acid when compared with only acetic acid, right? Only acetic acid. Why? Because in acetic acid there is no halogen atom on the alpha carbon atom. Is it clear, students? Okay, students, thank you for watching this video. If you feel good, kindly like the video and share the video among your friends, and also subscribe to my channel. Thank you so much.